In this video we'll look at the laws of logarithms and how we can simplify logarithms to make them easier to solve. Right, let's do this by a little investigation. See here on my calculator I typed a few things. And do you see a pattern? Log 7 plus log 4 is the same as log 28. Log 4 plus log 5 is the same as log 20. 7 times 4 is 28. 4 times 5 is 20. So it seems like log A plus log B is log AB. Let's check some other numbers. Well, 6 times 1 is 6. This is kind of obvious because log 1 is 0, so that's a special case. Let's try some other numbers. Log 6 plus log 10 is log 6 times 10. Yep, works. How about let's try some big numbers. Yep, it works. Couldn't do that in my head, but it works. Let's try some small numbers, some decimals. Yep, it works. So this is a rule we know that works. Log A plus log B equals log AB. And just so you know, it works for any base. This is of course base 10, but it'll work for any base. Let's look at this pattern. Log 20 minus log 5 is the same as log 4. Log 18 minus log 6 is the same as log 3. What do you notice? 20 divided by 5 is 4. 18 divided by 6 is 3. So it's log A minus log B equals log AB. Sorry, A divided by B. Let's try this with some other numbers. So it works with little small numbers, works with big numbers. So there's another rule. One more pattern I've noticed. Log 9 is the same as 2 times log 3. If I double that again, I get this one, which is log 81, which is 9 squared. But it's also 3 to the power 4. So do you see the pattern? Log A to the power x equals x log A. Let's try some other numbers. Okay, 2 to the power 8 is 256. Log 256 is the same as 8 times log 2. So yep, it works. This is 10 to the power 9. So log of 1 billion is 9, or it's 9 times log 10. Log 10, of course, is 1. I didn't need a calculator to do that. So look at that. We've just discovered 3 laws. Now, if I had more time, I could show the connection between these and the exponent laws. When you multiply exponents, you add the powers, right? When you divide exponents, you subtract the powers. It's just the opposite here. When you add logs, you multiply the argument. When you subtract logs, you divide the argument. And raising a power to a power, you multiply. Okay, what can we do with these laws? Well, first thing, we've got to memorize them. Then what can we do with them? We can solve questions like this. Write as a single logarithm. We can take this complicated thing and make it into one small log. So, here, log base b of x plus log base b of y, that's log base b of xy. And then now we subtract log base b of z, so we've got to divide. So that's the answer. So these 3 logs became 1 log. Over here, well, we've got to use the third law first. We've got to get rid of the 2 and the 3, so we just have logs. So we do that. 2 log x is log of x squared. 3 log y is log of y cubed. Okay, and subtract, so we're dividing. Okay, so the fact that we can make 2 or 3 logs into 1 log is really useful when it comes to solving questions like these. Now here we've got 3 logs equals 1 log, or 2 logs equals 1 log. We can use the same principle to solve for x. So first thing you need to do is get rid of the numbers at the front by making them the powers. Okay, so 5 squared is 25, 9 to the half is 3. And look at that, we've got log 3 minus log 3, so that's obviously 0. So log of 25 equals log of x, so that means 25 equals x. Works with any base, as you can see. There's b for base. Okay, last one. We've got a plus here. We've got the same base everywhere, so that's 8x squared. We got log of 8x squared equals log of x, so 8x squared equals x. Take x from both sides, factor it out, solve it like a quadratic, and that's your answer. But no, it's not, because log of 0 doesn't exist. So the answer is x equals 1/8. Okay, so I hope that little summary of log laws, let me highlight them again. That little summary of log laws really helps you remember these and see how they're useful. Good luck solving your questions.